Hello YouTube, this is WF7i Homebrew, and so here's another installment in my very slow, gradual process of building a direct conversion 3-band receiver. So my last installment, I just showed you that I had finished building the 3 oscillators. So there's an 80 meter, 40 meter, and a 20 meter oscillator. VFO, I guess maybe is a better way to say it. So I built sort of a tri-band VFO, and now I am to the stage where I need to hook the mixer up, the NE602, up to the 386 audio amplifier. So one of the things, if you look at this circuit diagram that I'm roughly following, you see that the NE602 has these 2 input pins here, 1 and 2. And so that's the input to the mixer chip, the doubly balanced mixer of the NE602. And so the signal comes in through the antenna port here, and this circuit's a little different from mine. They do some tuning of there's an attenuator. I also have an attenuator on mine. But then they have this kind of tuned LC network in front of the NE602. I'm not quite doing it that way. I am going to put some filtering in front of it, though. That's yet to be done. I am going to do some of that. But one of the things that I'm doing is I'm matching roughly anyway, and I'll show you in a second. I'm going to be building a match from roughly 50 ohm antenna to this 602 chip. So I'm going to have some filtering there. So basically a bandpass filter is what I'm planning on doing. It might only end up being a high pass and a low pass or something. But the idea is to have bandpass filtering for each of the 3 bands that's switchable. And then I will have a transformer that transforms 50 ohms to roughly somewhere in the neighborhood of 1500 ohms. That's the input impedance of the 602 chip. These pins 1 and 2 are expecting about 1500 ohms. So how do you do that? Well, the way I'm going to do it is to build a little transformer. And that's what this guy is over here. So this is a toroidal transformer. It's kind of a mess of wires. YouTube does not do it justice in my lighting and my camera and everything else. But what you're looking at there is I believe you'd call it a quadrifiler transformer. So I took 4 wires, twisted them together, wrapped them around a toroid. If you're new to this sort of thing, that probably doesn't make a whole lot of sense why I would do that or how that works. I'm not sure I can explain it, but I will do my best. So one of the things I'm going to show you is a little diagram that I sketched out. And again, I'm doing everything by hand right now. Eventually, some of this will be on CAD. Let me zoom back out a little bit if I can. There we go. It's a little better. Good old iPhone here. So this is my rough sketch of what I did here. And so each wire, I'm going to use a pencil because my finger seems to be too big for this. Each wire here is a different color. So this is a green wire on this leg. This is sort of a pale red color. I put a number 2 there. This is bright red over here, and this is a kind of a copper color wire. So I have 4 different colors, 4 different wires, and where you see this looks like it's continuous, what I did is I soldered, the pale red to the green at this junction. I soldered the bright red to the pale red at this junction, I think, if I'm reading it right here. And then I soldered the copper colored wire to the bright red wire at this junction. Okay, and so what's going on here? So this is roughly a 16:1 balun, so that's the transforming ratio of the resistance. In terms of voltage, it's 4 to 1. So if I put this on an oscilloscope, I put a signal into the input, the output I'm going to see 4 times the voltage. The way transformers work is you take the ratio, turns ratio, you square it, and that gets you the transformation of the impedance ratio. So the input, the way I have this designed, is between this port here and this port here. So I put antenna here, I put a ground symbol here. So in my case, this is the number 2 wire here. I label it number 2. That's the pale red wire. So the pale red wire, I wrap it around the toroid. So I need about 10 turns, which I sketched up here in this other chicken scratch drawing up here, which I'm not even going to try to go through that. It's even more unclear. And the core up here, it's a FT50-43. That just happens to be one of the toroid cores I have in my junk box. But it's not a random choice. The reason I use that one is because of the characteristics of the core. There's a website I can share with you at the bottom where you can plug in the core that you have, and you can, for a given number of turns around that core, it'll tell you what the impedance is at a given frequency. And so if you choose the wrong type of core, and you do, let's say you did 10 turns on a different core with different characteristics, maybe the permittivity is a little different. You might end up with a situation where the impedance of this connection between ground and antenna is very, very low. Maybe it's just a few ohms. So when I put a signal across something like that, if this is just a few ohms impedance of 10 turns around my toroid, it's going to look like a short circuit. You're not going to really develop much voltage across that. It's going to be, it's not going to really work too well. So you want to have a toroid of the right characteristics so that when you use a reasonable number of turns, you will have a pretty high impedance at that frequency. And that way you can sort of develop a reasonable voltage across that impedance. And that way you can actually see transformer action, because if you don't really have any voltage, you're not going to really transform much of anything. And some of this I really kind of learned, honestly, through trial and error and brute force. I mean, there is theory behind it. I have electrical engineering training. I took some courses, yada, yada, yada. But honestly, a lot of the things that I've learned is through the bench and through the oscilloscope and trying different things. And that's something that you just kind of learn. I think you wind a bunch of these and you study them on the scope with a signal generator. You can learn a lot about toroids, different types of cores and windings. Of course, there's theory on the web. You can read all about core material types, the optimum core for optimum purpose. This is not optimized what I'm doing here, and I'm sure people could find fault in it and say, well, you should have used this other core, whatever. But I think this will be good enough. I think it will work. And I've used it in another design that works pretty well. So I think this will work fine for me. And so anyway, and I'll share a link. Like I said, there's a nice app, not really app, but there's a nice website that you can go to, and you can try different combinations of turns, frequencies, cores. It's kind of fun, actually. I think transformers are pretty interesting anyway. So going back to this diagram, if I can talk, ground is on this side of the toroid, antenna is on the other side. This is my wire, the pale red there. So I have 10 turns of that. I apply a signal there from my signal generator, let's say at 3 megahertz. That's as high as this one signal generator will actually go, is 3 megahertz. So what happens? Well, I have these other 3 turns here. Well, let's look at this turn, these 10 turns over here. So all 4 of these wires are twisted together. So it's almost like one wire. But they are 4 separate wires. So what I do is at the end of this wire here, I solder it to sort of, you could think of as the beginning of the green wire over here. So physically on the toroid, this side of that green wire is on the same side of the toroid as this side of that bright red wire. So the way I think of this is kind of like this side of the toroid's at a lower potential than this side. This is at a higher potential. This one's at ground potential. This is at kind of your higher potential. And so what happens is if I start another winding at this ground potential and work my way this way, as I go down on my turns, as I get through the 10 turns down to this bottom, I'm going to develop more voltage. The voltage is going to increase, become more positive, because I'm going from that ground side up to the antenna side. So kind of the way you can sort of think of it is the flux, the magnetic flux. With the coil, you're inducing more positive voltage as I go down this way. And so you see that in the scope. When I put my scope probe over here, I'm going to have twice as high a voltage on this port as I do at this port. So it's kind of like stacking batteries. If I have 1 volt here, I'm going to have 2 volts over here. If I have 10 volts here, I'll have 20 volts down here. And the opposite happens on this side. If you look at this, so I'm taking that ground side, I'm jumping over to the antenna side of the toroid, and I'm going down towards the ground side. So as you might imagine, I'm starting from this ground potential, because this ground is hardwired here, so this has to be at ground potential right here. Starting there, and I'm going even kind of more negative, as you can think of it. I'm going towards the ground side. So when I put a probe here, this is going to be more negative. This is going to be below the ground potential. So if this is at, this is at 0 volts, this is at 1 volt, this will be at minus 1 volt. And over here, this will be at minus 2 volts. So what happens? So if I have 1 volt from the antenna port to ground, then over here from ground to green, it's going to be 2 volts. So it's twice as much signal. If I look over here, again, twice as much. It's going to be, in the negative side, it's going to be 2 times, minus 2 volts, whereas that's 1 volt. If I take the potential between this probe and down here, or I can look here and here, that's going to be a total of 4 volts, because it's plus 2 all the way down to minus 2. My peak-to-peak voltage is 4. Here my peak-to-peak was 1. 4-to-1 voltage transformation, or 16-to-1 impedance transformation. 16-to-1, the reason I do that is because I want to get as close to 1500 ohms as I can. And I don't know how to design an exact balun to get me to 1500, but this will get me to 800, from 50 to 800 ohms. That's what this balun's going to do. And I calculated the VSWR for 800 to 1500. It's about 1.8 to 1. It's not perfect, certainly, but it's reasonable. I mean, this is a receiver, it's not a transmitter. And so, it's a pretty decent match, not perfect, but it should do the job, I think, pretty well for receive. Unless you get a VSWR of like 10 to 1 or something, a lot of times you don't really notice it that much. So it's reasonable. My antennas and everything are tuned. I have pretty good antennas at 50 ohms. I'm sure one could design a perfect balun. I just don't know how to do it, and I'm kind of restless. I want to get this project done. So for now, this is what it's going to be. And so just to wrap things up, and I have the circuit here, and I have the scope displaying the signal. It's a little flaky here, and I'm going to see if I can get the camera to show the waveform. And let me just zoom in on that thing there. So the orange waveform is from ground to one of the sides. I forget if it's either copper or green. And I got some loose wires here. The yellow is from ground to the other side. So you can see they're equal and opposite polarity. Oftentimes that's what you see on balanced systems, balanced lines. You will have equal and opposite polarity signals on each of the 2 balanced lines. And that's exactly what this is going to be. And this will be the type of signal from the antenna that will be presented to the NE602 chip at pins 1 and pins 2 for this circuit. And it should be, like I said, pretty well impedance matched. The only thing I'm missing right now is the bandpass filters, and you do have to put some filters with this circuit because otherwise you'll get a lot of out-of-band hash, broadcast breakthrough, and intermod and whatever. A lot of junk comes in from strong out-of-band signals if you don't put some filtering. So I think that's about it for now. I'm going to cut this off because it's already 15 minutes long somehow. I do not know if this is interesting to anybody. If it is, give me a thumbs up, leave a good comment. What I will do probably after this is do some videos on the actual operation of the circuit because I'm getting pretty close. Now I may do some videos on designing the low pass filters. That's a little bit more involved, I guess. I have a little VNA that I'm going to try to use that I'm still not quite sure how to use. So I need to train myself how to do that first. And then I will build some little simple LC kind of bandpass filters, and then we'll get the show on the road. I'm probably going to go ahead and see if the radio works without the filters first, just to make sure everything's working. The final touches will be with filters, and then of course putting the box together, probably spray painting it, putting labels on, all that kind of fun stuff. You know, you can go on and on with these things. All right, well, thanks for watching, and 7 threes, everyone.